The next thing we need to talk about is which type of graph is most appropriate for displaying our data. There are several different types of graphs we will create. One of the things you have is the 10 Commandments of graphing, and you should read through this. You might want to pause here if you haven't already done so and read through this document. We are going to put this into action, and I will talk about each of these different components as we go through our graphs. So I'm not going to do that now because it kind of comes into play when we go through and we plot things. Representing and displaying data. We have all different types of graphs: bar graphs, line graphs, frequency tables, histograms, circle graphs, stem and leaf plots, scatter plots, dot plots, and box and whisker plots. When we're representing the data, it's important to determine which is the most appropriate. So go ahead and read through the next page, and then we'll talk about creating bar graphs and line graphs. Bar graphs are used to compare data and show trends. They show relationships between groups and things being compared. It's a fast way to show big differences. So as you can see by looking at this graph here, you can easily determine which type of fertilizer had more of an effect on the bean plant growth. Line graphs, on the other hand, are used to show change over time. They show a continuation of data, how one thing is affected, and it's clear to see by the rise and fall of the lines what's happening over time. So as you can see by the data below, we had two different pieces of data that we were comparing, Mabel and Albert, 36-year-old and a 26-year-old, and we're comparing their heart rates over time. Circle graphs are used to show how something relates to the whole. Histograms. Histograms show data that's been organized into intervals, and we're going to talk about creating those intervals later on. It's used very often for similar reasons as a bar graph between groups, but it's going to be a little bit different because of that interval component. So pause here, read through these next 6 questions, and tell me what you think would be the best graph for each. In the first one, the key word is interval, and we would use a histogram. In the second one, most people like the color blue. We're having different colors. We're comparing them. I would typically say a bar graph, although a circle graph is sometimes appropriate there as well. This is over time, number 3, so that would be a line graph. When we look at number 4, this shows part of the whole class. Again, here you could either use a circle graph or a bar graph. Mrs. Drews wants to survey a group of students to see how many books they read. Now, depending on what you get for your data, you could either use a bar graph or a histogram. A bar graph would be used if your data is very close together and you don't have a lot. If there's a great variation, then you might want to use a histogram. And Mrs. Sackett weighs her baby at the end of each month to see how much weight he had gained. That's over time again, so that's going to be our line graph. So let's go ahead and complete creating and reading some of these documents. Bar graphs, when we want to compare quantities or amounts. And if you want to go ahead and read those questions below, you can go ahead and pause here and do that. What information is this bar graph showing? Who sold the most lemonade? And how many people were selling lemonade? That would be 4. Who sold the most? That would be Tim. We had 19 glasses that he sold. Ellen sold the least. Jonathan sold 16. Tim sold 3 more glasses than Jonathan. And the same number of glasses was sold by Diane and Jonathan. And how many glasses total? We add them all up and we get 64. Pretty straightforward. Let's go ahead and create a bar graph now. For our first bar graph, we took a survey to determine amongst the flavors given to you what was your favorite ice cream flavor. That information is here. So what we need to do now is create a bar graph. And the frequency table just tells us how many people preferred each ice cream flavor. So the frequency of favoring that flavor. We'll create a bar graph using this data. Now what you're going to want to do is we're going to put the flavors down here and the number of students over here. And you're going to have to calibrate your vertical axis, your y-axis. The highest number is 5, so you do want to use most of that space, and you'll just break it out 5, 4, 3, 2, 1, and mine's not that equally calibrated. You want to use a ruler to do yours to get it equally calibrated there, measure it out. And then our bars are also going to be equally spaced. So you're going to have 4 different bars. You want to make them the same width. These are obviously not accurate, and you want to fill that in. So why don't you go ahead and try this on your own and come back and check with me. My bar graph looks like this. So notice that I have a label on each side. I have my ice cream flavors down here, and then I have my number of students on my y-axis, and then I also have the scale there. My scale is equally spaced, my bars are equally spaced, and then I labeled each bar. So your graph should look like mine, and we do need one more thing on this graph, and that is a title for the graph. So you would write first period favorite ice cream. Kind of messy, but you get the idea. So to create a double bar graph, we would use that when there's more than one set of data, and it uses pairs of bars to compare and show their relationship. For instance, I'm comparing 2 different periods of 8th graders, and I surveyed them to find out their favorite football team. I'm going to compare period 4 to period 8. And basically what I need to do is put my number of students here on the y-axis, and I'll put the teams on the x-axis, and then I'll have a key. So I'll have maybe this for period 4, the blue, and for period 8 I might have red. And then I'm going to put my teams that I have here. So for instance, I have the Giants, and then I will graph. I'll put my numbers along here, and I will graph it. So I would have a period 4, and then I would have a period 8, or whatever the case may be. So you guys should pause here and create this on your own. Come back and check with me. So here's the bar graph that I got, and notice I have a key for each period. I have my Giants, my Patriots, my Bills, and other. I can easily determine for which periods has a distinct difference in their opinions and which ones are kind of close. All kinds of things I can look at in that bar graph. Line graphs are next. You should use line graphs when we're comparing changes over time. All right, so every line graph needs a title and a label for each axis and a scale for each axis. So if we look at the first graph, it's saying what was the temperature at various times of the day on February 10th, 2004. So I'm going to put the temperature along my y-axis, and notice how I have scaled that out. So each line is going to be 5 degrees. I also need to tell what I am using. Dollars, cents. This is Fahrenheit. It could have been Celsius, so you need to be specific. And then I'm going to go ahead and I'm going to start my graph here at 1 p.m., 2 p.m., 3 p.m., 4 p.m., and I go up to 5 p.m. Now you could have started on the first line. It really doesn't matter. Just make sure to give yourself a title and go ahead, plot those points. Now the key with a line graph, you're plotting each one and connecting it as you go. So at 1 o'clock I had 25 degrees. I'm going to start here. Then at 2 o'clock I had 20 degrees. So I'm going to go here, make a line. Then I go to the next one. 3 o'clock was 30. Connect with a line, and so on. So go ahead, create this line graph, and come back and check yours with mine. Okay, so our temperature is on 2/10/04, and as you can see in my graph here, I did move the 1 o'clock over. You don't have to. It could have started at the first line the way I started it also. What I'd like you to do is, if you did okay with that one, pause here and go ahead and do the next 2 on your own, remembering titles and to show your labels along the sides, etc. Number 2, we were looking at movie attendance, and we went from our low value of 20 up to 48. Now again, you could have used a lightning bolt, and you could have made that like a 20 and then gone 25, 30, 35, 40, 45, 50. You could have done that. This allows you to make one adjustment to your scale, one adjustment only, and only at the beginning. So you could have done that if you chose, and then your graph would look a little different than mine. The next graph, we had the federal minimum wage over time. I started with 1950, went up to 1990, and my scale was 50 cents for each line. So however you determine to do that is fine. If you want to check it with me, that would be fine. You can check tomorrow. Now we're going to do a double line graph. We're going to compare inches of snow in Rochester to Buffalo over time. So what I did is I created a scale of 369. So notice my 0 first, then 369, just because that's kind of the way it works out. Want to have a label along the side, inches of snow, or you could put snow in inches. And then we're going to have our months along bottom here. So month. Now notice that we do skip the summer months, with the exception of May, because we did get snow in May. So you'd have January, February, March, April, May, and then we skip to October, November, and December. So go ahead, create that graph, and come back and check. Make sure you don't forget a key. You can do dotted versus solid. You can do color, whatever you choose to do that makes it distinguishable. Here is my graph. I did dotted and a different color just to make it fancy. And the key is up above, and I have my months and my inches of snow, and we're good to go. Pretty straightforward, so hopefully you didn't have too much trouble with that, and we'll practice more tomorrow. Have a great night, everyone.